Okay, so you've given us some really fascinating material to work with here. And we're going to do what we do best, dive deep into it. But, the mission here is to find those like nuggets, the crucial insights, and give you a clear picture without overwhelming you with too much.
Yeah, and what's so cool about these sources you've given us is that they give us this totally different way to look at these huge societal issues we're facing. And it comes from a perspective that you might not expect, mechanical engineering.
That's right. The big idea we're playing with today is an analogy between the way societies behave and the way mechanical systems work, which is really interesting. And of course, we've got to be clear up front that we're not saying people are robots or that societies are literally machines.
Right.
But the principles that govern how mechanical things work and also how they break down can be super insightful when we're trying to understand, our own crazy complex world.
Absolutely. And to kind of give this mechanical perspective some real weight, the key sources we're looking at is actually co-authored by someone with a PhD in mechanical engineering, Dr. Lev Nemotin.
Okay, so this guy knows his stuff.
He does, yeah. So his expertise really gives us a solid base for understanding these concepts and how they might apply to, bigger picture stuff.
All right, so let's lay the groundwork here. To get this analogy, we need to start with some basic physics. Specifically, this idea of resonance. So the physics world, what exactly are we talking about when we say resonance?
So at its core, mechanical resonance is all about this rhythmic motion, these oscillations. Picture a kid on a swing.
Right.
It's got its own natural pace, swings back and forth a certain number of times every minute.
Yeah.
If you give that swing a little push and you time that push just right so you're matching the swing's natural rhythm, something interesting happens. Even those small pushes, if they're timed consistently, can build up and that swing will get crazy high. That's resonance in action. Small periodic forces building up into this dramatically amplified motion.
It's like you're hitting it at the exact moment it wants to go in that direction anyway.
Yeah, exactly. You're adding energy at just the right frequency and it compounds. It's almost effortless to get that swing really high.
Right.
But I think you can already see how this resonance thing could become a real pain when you're dealing with systems that are way more complicated than a playground swing.
Oh, yeah, for sure.
Right.
So, thinking about that,
yeah,
you've got this potential buildup of energy that could be dangerous.
Mm-hmm.
And then another concept that keeps popping up in these sources is friction. So we tend to think of friction as a good thing, right? It slows things down, gives us grip. It's generally kind of a stabilizing force in our minds.
Mm-hmm.
But the material you shared, it suggests that it's not always that straightforward.
Yeah, that is a really key point to understand. I mean, you're right. Friction definitely has stabilizing effects in a lot of everyday situations, especially simple ones. But when we start looking at more complex systems with a bunch of different forces at play, all interacting with each other, the role of friction gets way more nuanced.
Okay.
In fact, under the right conditions, friction can even make things less stable.
So this is where it gets really interesting for me. How can friction, which we usually think of as slowing things down, actually cause instability?
Okay, so imagine you've got a system where you have all these different forces kind of pulling it in different directions. They're all competing with each other. Friction's going to act as a resistance to whichever motion is strongest. So it'll slow down whatever force is kind of winning that tug of war at that moment.
Okay.
Now, on the surface, that might seem like it's bringing things under control, like it's damping things down.
Yeah.
But the thing is, friction also works against the forces that are trying to correct the system.
Right.
Those negative feedback mechanisms that naturally would bring things back to a stable equilibrium. Mm-hmm. So yeah, it might be hindering one extreme, but it's also weakening the system's ability to regulate itself and kind of find that balance point again.
Oh, that's a really interesting idea. It's not just like a straightforward brake pedal on the system.
Exactly.
And the sources also talk about how there are different types of friction to consider, right?
Yeah, exactly.
Like you have this idealized version, and then there's what actually happens in the real world.
Yeah, precisely. In a perfect theoretical model, we might imagine friction as purely kinematic. It's just a resistance to motion. But in the real world, friction is dissipative.
Okay.
When surfaces rub together, energy doesn't just disappear, it gets converted into heat. And this has a really big consequence for how the entire system behaves.
So what is that consequence then?
Well, dissipative friction takes away from the total amount of energy that's available within the system.
Okay.
And it doesn't just target the forces that are pushing the system out of whack. It's like a passive damper. It bleeds energy from everything. The destabilizing forces and the ones that are trying to restore stability.
So if friction is constantly kind of draining the energy from the system, what's the net effect? Is it more stable or less stable?
So from a purely mechanical standpoint, dissipative friction can actually make things more stable, but it's a bit like using a sledgehammer to crack a nut.
Okay.
It stabilizes things by just generally reducing the energy in the system, which in turn lowers the chances of those runaway resonance amplifications.
Right.
But the trade-off is that it also makes the system less responsive, like less able to react to changes and correct itself quickly. It's this blanket damping that affects everything.
It's like throwing a heavy blanket over the whole system.
Right.
It might stop the shaking, but it also makes it hard to communicate or make adjustments.
Exactly.
Now, I know the sources also mention situations where resonance is actually something you want, like with lasers.
Yeah.
How does that fit into this picture?
That's a great point. In laser technology, we actually harness resonance intentionally to make the light energy stronger. You have these light waves bouncing back and forth between mirrors, and if they're at just the right frequency, they reinforce each other, they build up, and you get this super powerful focused beam. It's this carefully designed positive feedback loop.
Okay.
But, and this is key, the big difference here is that these laser systems are closed, they're precisely tuned, and someone is controlling them from the outside.
Right.
We don't just let them oscillate freely, we manage that amplification.
Right, so it's like very controlled amplification.
Exactly.
Which brings us back to the potential dangers of uncontrolled resonance. And the sources highlight some pretty dramatic examples of engineering disasters. I think the one that most people remember is the Tacoma Narrows Bridge collapse.
Oh, absolutely. Galloping Gertie, as they called it, collapsed back in 1940, and essentially what happened was a steady wind just happened to match the natural frequency of the bridge.
Wow.
The oscillations started small, but they kept building and building, twisting and contorting the bridge until the whole thing just, couldn't hold itself together anymore.
Wow.
The original design just didn't have enough damping to counteract that resonance. It's this really stark visual reminder of how powerful this phenomenon can be.
Yeah, I mean, it's hard to even imagine. So that wasn't just a freak accident, was it?
No, not at all. Resonance-induced failures, they happen all the time in engineering. Think about shaft whirling in high-speed turbines.
Oh.
The vibrations can become self-sustaining and incredibly destructive, like literally ripping the machinery apart.
Wow.
And then you have aeroelastic flutter in aircraft wings. The aerodynamic forces interact with the wing's flexibility, and it can lead to these violent oscillations that can, in the worst case, rip the wing right off the plane mid-flight.
Oh my gosh. Yeah. It's terrifying.
Yeah, and even in industrial machines that seem super stable, there can be internal coupling instabilities that can trigger dangerous resonance. The basic principle is always the same. If you don't have damping mechanisms in place, resonance is going to lead to this dangerous buildup of energy.
And potentially catastrophic failure. Right. So we've talked about how resonance and friction work in these mechanical systems, and we've seen how they can lead to both controlled energy amplification and also these devastating uncontrolled oscillations that can cause things to just fall apart.
Right.
But this is where the analogy really comes into play, and honestly, this is where things start to get a little bit alarming.
Yeah.
Because these sources are suggesting that our societies are a lot like these machines. We're constantly being acted upon by all these forces, and they often kind of work against each other.
Yeah.
What are some of the main forces that are at work here, in this social context?
Well, when you look at any society, especially a diverse one like ours, you've got this constant back and forth between different political ideologies. They're all competing for influence.
Right.
You've got economic interests that are often at odds with each other. And then you have cultural movements that are constantly pushing for change. And then on top of all that, you have the checks and balances that are built into our institutions, which are supposed to keep things from going too far in any one direction. In a society where these forces are all pretty evenly matched, which is kind of like what we're seeing in the US right now, the whole system can end up in a state of really high tension. It's like a precarious balancing act, a quasi-equilibrium.
It's a bit like two tectonic plates grinding against each other. Like, there's all this stored energy there, and it feels like something has to give eventually.
Exactly. And just like in mechanical systems, you can get these feedback loops that emerge between these social forces. One group takes some action, and it provokes a huge reaction from another group, which then leads to an even more extreme response.
Yeah.
And that creates this reinforcing cycle, this back and forth that can start to oscillate at what you might call the social system's natural frequency.
What are some of the things that really drive this social resonance? these escalating cycles of provocation and response?
The sources point to a few key factors. The media, of course, plays a big role. With the 24/7 news cycle and everyone's focus on conflict and division, it's constantly amplifying these oscillations. Identity politics, which is important, for representation and addressing past injustices, can also lead to these really strong us versus them dynamics, which just feed these cycles of antagonism.
Yeah.
But I think one of the most concerning things is this increasing ideological isolation. People are mainly interacting with others who already agree with them.
Right.
It creates these echo chambers where the oscillations just get more and more intense. You don't get exposed to any dissenting opinions or alternative perspectives.
This all sounds so familiar. Like, it's exactly what we see happening around us today.
Yeah.
These endless cycles of conflict that never seem to resolve. I think the sources call it the feedback problem.
Yeah, exactly. When different groups in society get locked in this adversarial dynamic, it's amazing how predictable their responses to each other become. It really does mirror that resonant frequency problem we talked about in the mechanical world.
Mm.
The inputs, the social or political actions or statements, whatever they hit, at just the right rhythm to make those societal oscillations even bigger. The peaks get higher, the valleys get lower.
So what does that actually look like in the real world? What are the consequences of this social resonance? What happens when a society starts to experience these uncontrolled oscillations?
Well, we're seeing it all around us. The rhetoric in our political discourse is just getting more and more extreme. It's like each side is trying to outdo the other with more inflammatory language. Then you have the institutional gridlock. Nothing gets done. It seems like finding common ground and actually passing meaningful legislation is almost impossible. And then there's this growing disillusionment with our institutions and with democracy itself. People are losing faith.
Yeah.
And maybe the most worrying thing is this fragmentation of reality that's happening. Different groups can't even agree on basic facts anymore.
Yeah.
We don't have a shared understanding of events.
Right.
And that erosion of a shared understanding, that's a really dangerous sign.
It is. And it seems like social media, with its algorithms and the way it's designed, is really playing a huge role in amplifying this whole destructive cycle.
Absolutely. The way those algorithms are designed, it's all about maximizing engagement. And unfortunately, what gets people engaged, emotionally charged content, appeals to identity. It's all designed to trigger those primal instincts, and it just fuels this tribal behavior online.
Yeah.
It creates these online echo chambers where these resonant cycles can just spin out of control, feeding off outrage and reinforcing people's biases.
So it's almost like you're pouring gasoline on a fire that's already out of control.
Exactly. Now, just like with mechanical systems, there's friction in social systems too. Things like bureaucracy, those long legal processes, even just voter fatigue,
Right.
People just get tired of it all. And the sources suggest that this social friction, it can play a kind of a double role. It can be stabilizing in some ways, but also, surprisingly, destabilizing. So how does that work?
Yeah. How can something that slows things down actually make things less stable?
Okay, so just like in a mechanical system, friction can be like a brake on society. It can slow down those rapid or drastic shifts that sometimes happen.
Okay.
So in that sense, it can create a degree of stability. It prevents things from changing too quickly, which can sometimes be a good thing.
Right.
But here's the thing. If you have too much friction, it can actually suppress those vital stabilizing responses that we need, like compromise, moderation, and just the ability to find common ground. When it becomes too difficult to enact solutions or bridge divides, both the folks who are pushing for change and the ones who are trying to maintain order become less effective. The whole system just loses its ability to self-correct. It's like trying to steer a car with the parking brake on.
Oh, I get it. So you're saying too much friction is not necessarily a good thing in a social system either.
Exactly. It can seize up those mechanisms of progress and resolution that we need.
This all sounds, I don't know, kind of ominous. I mean, the sources actually use the phrase danger of resonance-driven collapse when talking about societies.
Yeah.
Which, I mean, it sounds a little dramatic, but also kind of terrifying.
It is dramatic, and it's meant to be. The idea is that just as uncontrolled resonance can cause a bridge or a turbine to literally fall apart, societies that get caught in these amplifying cycles of conflict without anything to dampen those cycles, they could face their own kind of systemic collapse.
Oh.
Think about the potential for civil unrest. When people lose faith in the system and they feel like they're not being heard, they might resort to violence. Then you have the erosion of trust in institutions. They become delegitimized. People stop believing in them. And in a worst-case scenario, you could even have a breakdown of those basic norms and agreements that hold a society together.
It's like the social fabric just unravels.
Exactly. It's a warning about the potential for things to really go wrong if we don't figure out how to manage these oscillations.
It's a pretty serious warning. But the good news is that the sources don't just leave us hanging with this terrifying prospect. They actually offer some potential solutions, and they use that engineering perspective to do it. They talk about 3 key approaches, and the first one is identifying the drivers. So what does that mean in a social context?
It's like when a mechanic is trying to figure out what's wrong with your car. You have to diagnose the problem. You have to understand what's causing the symptoms. In a social context, that means figuring out the fundamental drivers that are fueling polarization and these dangerous feedback loops. It could be deep-seated ideological divides or the way the media operates, always focusing on conflict instead of consensus. It could even be structural problems within our political and social institutions that make things worse.
So the first step is understanding the root causes of the problem.
Exactly.
And the second remedy they suggest is modeling the feedback loops. But how do you even begin to do that in something as complex as a society?
It's about looking at how all these different factors we've identified, the drivers, how they interact and reinforce each other. Like, let's say a politician makes a controversial statement. How does that get covered in the media? And then how does that media coverage shape public opinion? And does that then lead to another political action or reaction? By mapping out all of these interconnected feedback loops, we can start to see how these escalating cycles develop, and maybe more importantly, we can find those points where we could potentially intervene and break the cycle.
So it's not about looking at isolated incidents, it's about understanding the system as a whole.
Right.
And the third remedy, which I think is the most interesting, is inserting what they call targeted damping mechanisms. So how would that work? What would these dampers look like in a society?
This is where we take what we've learned from engineering and apply it to the social world. Just like an engineer would design a damper to reduce unwanted vibrations in a machine, we have to think about how to introduce these mechanisms into society that can reduce the amplification of conflict.
Okay.
This could involve things like promoting media literacy, teaching people how to critically evaluate information and not just react emotionally to everything they see online. It could also involve political reforms that encourage collaboration and compromise instead of this constant adversarialism. And it might mean strengthening those institutions that are designed to promote reasoned debate and bridge divides between different groups. The goal is to find those pressure points where we can interrupt those resonant cycles without undermining the system's ability to adapt and respond to legitimate concerns.
That's fascinating. So it's about dampening the negativity without stifling the system's ability to evolve.
Right. It's a delicate balance.
So taking all of this into consideration, it seems like looking at our current social problems through this mechanical lens is a really powerful way to understand just how deep and systemic polarization is.
Yeah, it is.
And how dangerous those feedback loops can be if they're allowed to just spin out of control.
Right. And the key takeaway here is that a society that's deeply polarized and caught up in these intensifying cycles of conflict, it faces risks that are very similar to the dangers of uncontrolled resonance in a mechanical system. And just like engineers work really hard to prevent bridges and turbines from collapsing, we need to understand these social dynamics so we can prevent a potential societal collapse.
So as we wrap up this deep dive, here's something to ponder. Thinking about all these mechanical analogies we've been talking about, the underlying causes of these oscillations, those feedback loops that push us further apart, and the need for those targeted damping mechanisms, what specific dampers do you think would be most effective for dealing with the polarization we're seeing today? And, maybe even more importantly, how do we prevent those conflicts from getting even worse? It's something to really think about. Thanks for joining us on this deep dive. It's been a really thought-provoking conversation.
It has. Thanks for having me.